Alrighty, Mrs. Key. Let f be a function that is differentiable in the open interval. If f of 2 is negative 5, f of 5 is 5, and f of 9 is negative 5, which of the following must be true? So differentiable, that means we are continuous also. We have at least two zeros. Well, we're going to have a 0 in that interval, because 0 is between negative 5 and 5. And we're going to have a 0 between 5 and negative 5 again, so that's yes. It's because of IVT, which says if a function is continuous, then we must hit all y values in between the endpoints. So on this interval, we've got to hit 0, and then on the interval 5 to 9, we have to hit 0. The graph of f has at least one horizontal tangent. That one's yes, because the average slope between 2 and 9 is 0. So that means the instantaneous slope has to be 0 somewhere because of MBT. Because a function is differentiable, there is somewhere where the average slope equals the instantaneous slope. For some c, f of c is 3, between 2 and 5. Yes, that's again because of IVT, because 3 is between negative 5 and 5. So 1, 2, and 3. The function f is continuous for all real numbers, and the average rate of change of f on the closed interval is negative 3/2. So we're continuous, we're not necessarily differentiable. For 6 to 9, there is no value of c such that the derivative is negative 3/2. So that means there's nowhere the instantaneous slope is negative 3/2, but the average slope is negative 3/2. That means MBT does not work. So that means one of the hypotheses of MBT is not true. We have the continuity part, so it has to be the differentiability part. So I'm going to choose differentiable. Let me explain why the rest don't have to be true. Part A, I had to make sure I read it correctly. Part A, that's average value, so they want you to confuse average value and average slope. The integral has to exist because the function is continuous. This is the average of two slopes. I'm not sure what that gets me. And this is saying the derivative is less than 0, but I don't know that the derivative exists. So not necessarily less than 0. The function is defined as a relative max. So for 16, to find a relative max, let's take a derivative, 3x squared minus 6x. Let's set that equal to 0. Let's factor out a 3x. We get x minus 2. So if I create an f prime number line, I have a 0 at 0 and a 0 at 2. If I plug in numbers to the left of 0, so like negative 10, that's a negative, so overall we're positive because we are multiplying. If I pick the number 1, that would be 3 times negative 1, so that's negative. And if I pick the number positive 22, that's a random number, it does not matter which number you pick, we go positive. So we have a relative max at 2. We have a relative min at 0. For what value of x does the function have a relative max? So same question. So for 15, let's take the derivative. So f prime is going to be the derivative of the first times the second plus the first times the derivative of the second. I'm going to again set that equal to 0. I'm going to factor. So I'm going to take out x minus 3. I'm going to have x minus 3, that's a 2, plus 2x minus 2 equals 0. I'm going to clean up that second parentheses, that's x minus 3. That'll be x plus 2x, so that'll be 3x. And then negative 3 minus 4 is negative 7. So that means my zeros are 3 and 7/3. If I go back to here and I plug in a really big number, we'll have a positive. If I plug in a number between 7/3 and 3, so 8/3, that will be, let's see, this is just going to be a quadratic, so I don't have to think that hard. So this is going to be a quadratic. That's going to be concave up, so it's going to be positive, negative, positive. What am I being asked for? Relative max. So we have a relative max at 7/3. I'm going to let you do the free response yourself. And let's see what we have here. A tank has a height of 10 feet. Area, the horizontal cross-section of the tank at a height h feet is given by the function a, where a of h is measured in square feet, so that's square feet. Function a is continuous and decreases as h increases. selected values for A of H are given in the table above. Use a left Riemann sum, 3 subintervals, to approximate the volume. So volume is going to be the area of the base times the height. So that's A of H times H, and left Riemann sum. So the width of that first, I'll draw a picture for you. So we have 0, 50, 2, 14, 3, 5, 6, and then 10, 2.9. So my left Riemann sum is going to look like this. Heights come from the left. So the width is 2, height is 50. Width is 3. Height is 14.4. If you're confused about where I'm getting those widths, it's just the difference between those. And then between 5 and 10 is 5, and the height is 6.5. And I can do that calculation. I am allowed to use a calculator, so I'll go ahead and do that. 3 times 14.4, and 5 times 6.5. So that's 176.3. And my units are in square feet times feet, so cubic feet, so feet cubed. Does the approximation over or underestimate the volume of the tank? Well, this is part B. So, since A of H is decreasing, the left Riemann sum is an over approximation. And then 1C. The area in square feet of the horizontal cross-section at height h feet is modeled by that. Find the volume of the tank. So we have a height of 10 feet. And we now have this function. So that's going to be the integral from 0 to 10 of f of h dh, which if we put that in our calculator, we get 101.235. So that's 101.325, not 235, cubic feet. Water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at a rate of 0.26 foot per minute. Use the model from part C. Find the rate at which the volume of the water is changing with respect to time when the height of the water is 5 feet. Indicate units of measure. So we just figured out the volume, right? So the volume of the water is the integral from 0 to h f of x dx. So we want the rate at which the volume of the water is changing with respect to time. So we want dv dt. So that's just going to be the derivative of this thing with respect to t. So when I cancel, the integral will cancel out. So that's that fundamental theorem of calculus, the derivative portion. So when I take the derivative of that integral, I'm left with this jumps in. So that's f of h, and then chain rule, dh dt. And this problem is concerned at 5 feet. So I need dv dt at 5 feet, so that's h equals 5, is f of 5 times dh dt at 5. F of 5 times, and I can just find that on my calculator, times 0.26 is going to give me 1.694. So then you would say at h equals 5, the volume of water is changing at a rate of 1.694 cubic feet per minute. Yeah. Okay, let's look at this one. A metal wire of length 8 centimeters is heated at one end. The table above gives selected values of the temperature in degrees Celsius of the wire. Function t is decreasing, that I'm assuming is important somewhere, and is twice differentiable. Estimate t prime of 7. So t prime of 7. So we're trying to estimate a derivative, but we just have data points. So we want to find the average slope between these will get me somewhere close to the instantaneous slope. So t of 8 minus t of 6. You could have done t of 6 minus t of 8, I suppose. And that's 55 minus 62. 8 minus 6. And if you don't want to simplify, you don't have to. I will, because I'm a math magician. So that's negative 7/2. And my units are centimeters per degrees Celsius. Let's see what we have next. Write an integral expression in terms of T of x, the average temperature. Estimate the average temperature using a trapezoidal sum. Okay, so the average temperature is going to be add up all the temperatures, divide by the width. So that's my average temperature. So trapezoidal, I don't do trapezoids. I'm going to do left and right. I'm going to do it without the picture this time. So left is going to be 1 times 100, 4 times 93, 1 times 70, 2 times 62. And I'll go ahead and do that. This was a calculator question, so I can use that. 4 times 93, 70, and 2 times 62 is 124. So that's apparently the devil. And the right Riemann sum is 1 times 93, 4 times 70, 1 times 62, and 2 times 55. Notice on the right one, I pay attention to the rightmost endpoint. On the left one, I pay attention to the leftmost endpoint. 93, 4 times 70 is 280, 62, and 110. That's 545. So then my trapezoidal approximation, trap, is going to be 666,545 divided by 2. And so if I do 666,545 divided by 2, again, on the test itself, you don't have to do this calculation. You can just show the work. So then my approximation, go back up here, is the 605.5 over 8, which is divided by 8. 75, I'm going to write the whole thing, 6875. In my units, this is an average temperature, so degrees Celsius. And next, find the integral 0 to 8 of t prime. Ooh, okay. So, for part C, I have a different color. Integral 0 to 8 of t prime. Well, okay, so if I evaluate an integral, isn't that just t of x from 0 to 8? So isn't that just t of 8 minus t of 0? And I know what t of 8 is. So that's 55 minus 100. So that's negative 45. My units are degrees Celsius, because they're differences in temperatures. Explain the meaning. The meaning, not the meeting. I'm not going to write it down. I'm going to verbally explain it. So I'm going to think of this as the temperature of the wire decreases by 45 degrees Celsius over the 8 centimeters of the wire. You could also say, starting at the heated end, the temperature drops 45 degrees as you get farther away from that heated end, up to the 8 centimeters away. Rubric will say something like that. Okay. Are the data in the wire table consistent with the assertion t double prime is greater than 0 for every x in the interval? So t prime. Okay, so to talk about t double prime, if I consider t prime, if t prime goes down, then t double prime has to decrease, which means t double prime, has to be negative. So if I can find places where t prime goes from a number to a smaller number, or a more negative number, then that will work. Okay, so let's look at this. Look at that data in the table. The average slope between 6 and 8 is negative 7/2, because we found that. And the average slope between 5 and 6 is negative 8. And then negative 7. Okay, so I'm going to do that. So the average slope on 0, 1 is 93 minus 100 over 1 minus 0, negative 7. Average slope on 5, 6 is 62 minus 70 over 6 minus 5, which is negative 8. Since I underlined it, t is twice differentiable, there exists a C1 in I'll write it this way for you. I think it'll make more sense if I write it this way. A C1 between 0 and 1 such that, I'm trying hard not to write the mathematical notation I want to write. It's my hesitation. T prime of C1 equals negative 7. And I suppose for C1 there, C2, where C2 is between 5 and 6, such that, I'm using C because I'm using MVT, and MVT talks about C. T prime of C2 equals negative 8. Because of MVT, I guess I could say. Might be better to say because MVT states average slope equals instantaneous slope on a closed interval. This is wordy. For a continuous and differentiable function. I'll try to recap this a little better. Function. Okay. And I probably, I will rephrase this because I didn't do the best job here. I should have said, since t is twice differentiable, t prime is continuous. if t prime, since t prime, c1 is -7 and t prime of c2 is -8, t double prime must decrease somewhere on c1, c2. So t double prime is not always positive. Okay, not position positive. Let me recap because that was a whole bunch. Let me go back to the question. So are the data in the table consistent with the assertion that t double prime is greater than 0? So I looked for t prime values that decreased. I knew I could talk about t prime because t is twice differentiable. Since t is twice differentiable, that means both t prime and t double prime are continuous. And really I just care about t prime, so t prime is continuous. So since I found two places where t prime had to be decreasing from -7 to -8, t prime has to decrease. If t prime has to decrease, that means somewhere on that interval t double prime has to be negative because t double prime is the slope of t prime. Whew, there's a lot there. I'm going to look up how they phrased it also. So, no, my computer just died, so I'm going to do that not. You feel free to Google that and look up how they phrased it also, but I think it's probably the same argument. All right, let's see what this last one is. G is defined and differentiable. G of 0 is 5, so I'm probably going to need that somewhere. G prime consists of a semicircle, so this is G prime. Okay, G of 3. So G of 3. I know what 0 is, so that's the integral from 0 to... Ooh, don't do that. That's the integral from 0 to 3 of G prime of x dx. And I'm going to add 5 to that. So it's where I started plus whatever the change is. So that's going to be 5 plus this and this. So that circle is radius 2, so the area of that circle is 2 squared pi, which is 4 pi. I'm looking at a quarter of that. So that's pi. And then that triangle is 1 by 3. 1 by 3 divided by 2. And I would stop there. This is for A. And for G of -2, again, it's going to be 5 plus 0 to -2. Note we're going backwards there, so we have to think a little bit more. So 0 to -2 is this. Again, it's going to be pi. Because we are above the x-axis there, but we are going backwards, that integral is negative, so negative pi. Find the x-coordinate at each point of inflection. So we're going to argue G has a point of inflection when G double prime changes sign. Now in parentheses I'm going to also put this. G prime changes increasing to decreasing or decreasing to increasing. You don't have to put the part in parentheses, but you could use the part in parentheses instead of the G double prime argument. So I'm going to see that as so this is G prime. So G, and I draw on it. Positive slope, negative slope, positive slope, negative slope. So we changed right there, and right there. So that's going to be at x equals 0, 2, and 3. The function h is that find the x-coordinate each critical point. Classify each as a min, max, or neither. Oh goodness, okay. So h prime of x equals g prime of x minus x. So h of x has a critical point. Critical points show up when the derivative is 0 or undefined. This derivative never will be undefined because g prime exists and x exists. So when h prime of x equals 0, which means g prime of x equals x. Now I'm going to go to the picture. And I have all this stuff, so let me clear it first. And I want to know when g prime, which this is g prime, equals x. And so the easy one's 3, 3. And the hard one is along that circle. But the radius of the circle is 2. So that's 2. Well, and so this is going to be an isosceles right triangle because that's y equals x, which is 45 degrees. I don't know if this is the best way to think about this, but this is what's popping in my brain right now. That's 45 degrees. So that's an isosceles right triangle. This is 45, this is 45. So this is the square root of 2, and this is the square root of 2. Trying to think of various ways to think about this. So, for example, the sine of 45 is going to be like this over this, and you know it has to be the square root of 2 over 2, right? Okay, I did that. How I thought of it was the Pythagorean theorem. 2 squared is 4, so I need the two legs to add up to 4, so that's the square root of 2 and the square root of 2. So I'm going to have critical points. H has critical points at x equals the square root of 2 and at x equals 3. At x equals the square root of 2, we have to determine if we have a min or a max. So it's g prime minus x. If I take my g prime values, which are here, and I subtract x, I get a positive number. If I take my g prime values and I subtract x, I get a negative number. So max, because h prime goes positive to negative. And then at 3, if I take my g prime values, which is this, and I subtract x, I get a negative. And then same thing here. So neither, because h prime goes negative to negative. That's all I had to do. Yes. Okay, now, let's pretend you were confused by that. So what I was looking at, let me get rid of this stuff. What I was looking at was, I know that h prime is g prime minus x. These are g prime values and in the picture. So this g prime value minus this x value is going to give me some positive number because the g prime values are bigger than the x values. And then I just threw my pen at the computer. That was fun. This g prime value minus these x values are going to be negative because those g prime values are less than the x values. So we're going positive to negative on h prime. Similarly, these g prime values on both sides minus these x values give me negatives. Hence the nothing is going on there.